In this episode, we look at firewalls and filtering controls that help organizations decide which traffic should be allowed, blocked, inspected, slowed, or flagged for review. A firewall is one of the most familiar security controls, but the word can describe several different kinds of protection. Some firewalls focus on basic network details, such as addresses and ports. Others understand applications, web requests, user identity, threat signatures, or sensitive data patterns. You will also hear terms like Web Application Firewall, WAF, Unified Threat Management, UTM, Layer 4 filtering, Layer 7 filtering, rate limiting, and data loss prevention, DLP. These controls are related because they all inspect or control traffic in some way, but they do not all solve the same problem. The key is to understand what each control is best at stopping or detecting and where its limits are. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A traditional firewall controls traffic between networks or systems based on rules. Those rules may allow or deny traffic depending on the source, destination, protocol, port, direction, or connection state. You can picture a firewall as a controlled checkpoint between areas of different trust. A company may place a firewall between the internet and internal systems, between user networks and server networks, or between sensitive environments and general business networks. The firewall does not automatically know whether every action is safe. It follows policy. If the policy says only certain traffic is allowed to a server, the firewall helps enforce that boundary. This reduces exposure by preventing unnecessary communication. A server that only needs to receive web traffic should not also be reachable through unrelated management ports from the entire internet. Firewalls help narrow the paths an attacker can use. Filtering is the broader idea of examining traffic, content, requests, or data, and then taking action based on rules or patterns. A firewall filters network traffic. An email gateway may filter messages. A web proxy may filter websites. A DLP tool may filter outbound data transfers. Filtering can allow, deny, alert, quarantine, redirect, or rate limit activity. The exact action depends on the control and the policy. Filtering matters because modern environments are too connected to trust everything equally. Users browse websites, applications call outside services, remote employees connect through cloud platforms, and data moves constantly. Without filtering, the organization has fewer ways to shape that activity. Good filtering is not just blocking. It is making communication more intentional. It allows legitimate business activity while reducing risky, unnecessary, suspicious, or policy-violating activity. Layer 4 filtering focuses on transport-level information, such as Transmission Control Protocol, TCP, and User Datagram Protocol, UDP, ports, source and destination Internet Protocol, IP, addresses, and connection behavior. In the Open Systems Interconnection, OSI, model, Layer 4 is the transport layer. At this level, a firewall may allow traffic from a certain source to a certain destination on a certain port. For example, it may allow web traffic to a public web server while blocking management traffic from the internet. Layer 4 filtering is efficient and widely used because it can make decisions without deeply understanding the application content. Its limitation is that port-based decisions do not always reveal what the traffic actually contains. Malicious activity can sometimes travel over allowed ports. So Layer 4 controls are useful, but they may not see enough detail to catch application-level attacks. Layer 7 filtering works at the application layer, where the control can understand more about what the traffic is trying to do. Instead of only asking which port is being used, Layer 7 filtering may examine application commands, web request methods, headers, content patterns, user identity, file types, or behavior. For example, traffic using Hypertext Transfer Protocol, HTTP, may look normal at Layer 4 because it is using an expected web port. At Layer 7, a security control may see that the request contains a suspicious pattern, an attempt to upload a risky file, or a command that does not match normal use. This deeper understanding can provide stronger protection for applications, but it usually requires more processing and careful tuning. Layer 7 filtering is more context-aware, while Layer 4 filtering is more basic and often faster. A web application firewall protects web applications by inspecting web traffic and blocking or alerting on suspicious requests. A WAF is designed to understand common web application risks better than a basic network firewall. It may look for patterns related to injection attacks, cross-site scripting, malicious file uploads, protocol abuse, suspicious request formats, or attempts to reach hidden administrative paths. A WAF is often placed in front of a web application, so requests pass through it before reaching the application. This can reduce risk when applications are exposed to the internet or when a vulnerability needs temporary protection while developers work on a fix. A WAF does not replace secure coding, patching, authentication, or application testing. It adds a protective inspection layer that is especially focused on web application traffic. A WAF is useful because many attacks target the way web applications accept and process input. If an application accepts search terms, form fields, uploaded files, login attempts, or application programming interface requests, attackers may try to send unexpected input to make the application behave incorrectly. A WAF can help detect and block known attack patterns before they reach the application. It can also enforce rules about request size, allowed methods, approved paths, and suspicious behavior. The limit is that a WAF cannot fully understand every business rule inside the application. It may block obvious attack patterns, but it may not know whether a user is abusing a legitimate workflow in a subtle way. It also has to be tuned so it does not block normal users. The best role for a WAF is application-aware protection at the edge of web traffic. Unified Threat Management combines multiple security functions into one platform or appliance. A UTM solution may include firewalling, intrusion prevention, antivirus scanning, content filtering, virtual private network support, web filtering, spam filtering, and reporting. The appeal is simplicity. Instead of managing many separate tools, a smaller organization may use one integrated platform to provide several protections at once. This can make deployment and administration easier, especially when staffing and budget are limited. The trade-off is that one platform may become a concentrated dependency. If it is misconfigured, overloaded, or unavailable, several protections may be affected at once. AUTM may also not provide the same depth in every function as specialized tools. For Security Plus, think of UTM as an all-in-one security gateway that combines several controls into a single managed solution. Rate limiting controls how many requests, connections, messages, or actions are allowed within a certain period. It does not always block a type of traffic completely. Instead, it slows or limits volume. This can help protect services from abuse, overload, brute force attempts, scraping, denial of service activity, or badly behaving clients. For example, a login page may allow only a certain number of attempts from one source within a short period. An application programming interface may limit how many requests a client can send per minute. A web service may slow traffic that exceeds normal patterns. Rate limiting is useful because some attacks depend on scale and repetition. A single failed login may not mean much, but thousands of attempts in a short time are suspicious and harmful. Limiting the rate reduces the attacker's ability to overwhelm or guess repeatedly. Rate limiting also protects availability. Even legitimate systems can cause problems when they send too much traffic too quickly. A misconfigured script, broken integration, or runaway process may overload an application just as effectively as hostile traffic. Rate limiting gives the organization a way to preserve service for everyone by preventing one client, account, or source from consuming too much capacity. The challenge is choosing limits that are strict enough to reduce abuse, but flexible enough to support normal use. If the limit is too low, legitimate users may be blocked or slowed. If the limit is too high, attackers may still cause harm. Rate limiting is often more effective when combined with monitoring, authentication, reputation checks, load balancing, and alerting. It is a traffic-shaping control, not a complete security strategy by itself. Data loss prevention focuses on detecting or preventing sensitive data from leaving approved locations or being used in unsafe ways. A DLP tool may inspect email, file uploads, cloud storage, endpoint activity, print jobs, removable media, or network transfers. It may look for patterns such as payment card numbers, national identification numbers, health information, confidential labels, source code, or specific keywords. When the tool detects a policy match, it may alert, block, quarantine, encrypt, warn the user, or require approval. DLP is different from a normal firewall because its main concern is the data itself, not only the connection. The question is not just where traffic is going. The question is whether sensitive information is being exposed, copied, or transmitted in a way that violates policy. DLP works best when the organization understands its data. If the tool does not know what counts as sensitive, it may miss important transfers or create too many false alarms. Data classification, labeling, content inspection, fingerprinting, and policy design all affect the quality of DLP results. For example, a file labeled confidential may trigger stricter handling rules than a public document. A database export containing customer records may trigger an alert if someone tries to upload it to an unapproved cloud service. A user emailing a small number of approved records to an authorized partner may be acceptable, while sending thousands of records to a personal account may be blocked. DLP needs context because data movement is not always bad. The goal is to stop unsafe movement while allowing legitimate business processes to continue. These controls often overlap, but their best uses are different. A basic firewall may block unwanted network access by address and port. Layer 4 filtering is good for fast, transport-level decisions. Layer 7 filtering is better when the control needs to understand application behavior. A WAF is focused on protecting web applications from malicious web requests. A UTM brings several gateway security functions into one platform. Rate limiting reduces abusive or excessive volume. DLP watches for sensitive data leaving or being mishandled. If a scenario describes a public web application under attack through suspicious requests, a WAF is likely. If it describes limiting repeated login attempts, rate limiting fits better. If it describes blocking a spreadsheet full of customer data from being emailed outside the company, DLP is the better match. You should also understand the limits of these controls. Firewalls do not help much if the allowed traffic itself contains an attack that the firewall cannot understand. A WAF may not fix broken application logic. A UTM may become a bottleneck or single point of dependence. Layer 7 inspection may be more resource-intensive and may require visibility into encrypted traffic, which must be handled carefully. Rate limiting may slow an attack, but not stop a patient attacker who spreads activity across many sources. DLP may generate false positives when normal data resembles sensitive data and false negatives when sensitive data is hidden, encrypted, compressed, renamed, or moved through an unmonitored path. Security operations requires knowing both what a control can do and what it cannot do. That helps you avoid overtrusting any single protection. For Security Plus questions, focus on what the scenario is trying to stop or detect. If the question describes controlling traffic between networks based on addresses, ports, and protocols, think firewall or layer 4 filtering. If it describes inspecting application content, commands, or web request details, think layer 7 filtering. If it describes protection specifically for web applications, think WAF. If it describes an integrated appliance with firewall, antivirus, intrusion prevention, and filtering in one platform, think UTM. If it describes slowing repeated requests, login attempts, or excessive traffic, think rate limiting. If it describes preventing sensitive information from leaving through email, uploads, endpoints, or cloud services, think DLP. The exam often gives you more than one plausible control. Choose the one whose main purpose matches the risk described. The larger lesson is that firewalls and filtering controls are about making traffic and data movement more controlled, more visible, and less dangerous. A firewall creates boundaries between systems and networks. Layer 4 filtering makes fast decisions based on transport details. Layer 7 filtering adds application awareness. A WAF protects web applications from suspicious web requests. AUTM combines several security functions into one platform for simpler management. Rate limiting reduces abuse by controlling volume over time. DLP protects sensitive information by detecting or preventing unsafe data movement. These tools are strongest when they are matched to the right problem and layered with other controls. You do not need to treat them as competing answers in every situation. You need to recognize the job each one performs and the kind of risk it is designed to reduce.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.